Space is just the construct that gives the illusion that there are separate objects. Dr. Quantum. There is a phenomenon so strange, so fascinating, and so counter to what we believe to be the known scientific laws of the universe, that Einstein himself could not wrap his head around it. It's called quantum entanglement, though Einstein referred to it as spooky action at a distance. An experiment devised by the Griffith University's Center for Quantum Dynamics, led by Professor Howard Wiseman and his team of researchers at the University of Tokyo, recently published a paper in the journal Nature Communications confirming what Einstein did not believe to be real, the non-local collapse of a particle's wave function. Wiseman stated that this phenomenon is the strongest yet proof of the entanglement of a single particle, an unusual form of quantum entanglement that is being increasingly explored for quantum communication and computation. They did this by splitting a single photon between two laboratories, and testing whether measurement of it in one laboratory would actually cause a change in the local quantum state in the other laboratory. In doing so, researchers were able to verify the entanglement of the split single photon. Wiseman went on to state that Einstein's view was that the detection of the particle only ever at one point could be much better explained by the hypothesis that the particle is only ever at one point, without invoking the instantaneous collapse of the wave function to nothing at all other points. However, rather than simply detecting the presence or absence of the particle, we used homodyne measurements enabling one party to make different measurements and the other, using quantum tomography, to test the effect of those choices. In quantum mechanics, one or more particles can be described as a wavefunction that spreads over extremely large distances, but never detected in two or more places. Non-locality refers to measurements that are made at the smallest, microscopic levels. When scientists examine matter at this level, the laws of classical science, or classical mechanics, seem to be thrown out of the equation, and long-held notions about the nature of reality don't seem to apply anymore. This is what has baffled scientists for decades. Collapse of the wave function occurs when an observer is introduced. In essence, the very act of measurement changes that which is being measured. This is best illustrated by what is known as the quantum double-slit experiment. Particles are in many places at once, and exist in multiple probable states. This means that, as seen in the video linked in the paragraph above, if an electron was fired through two slits at a screen, it would go through both of them. However, once you introduce an observer camera's measurement, the particle only goes through one of the slits, rather than both. The very act of measurement, again, collapses the wave function. A paper published in the peer-reviewed journal Physics Essays by Dean Radin, Ph.D., explains how this experiment has been used multiple times to explore the role of consciousness in shaping the nature of physical reality. It's a great example of how the simple act of observation collapses the quantum wave function. Some physicists have felt that other physicists have taken these findings and drawn absurd conclusions about consciousness and the nature of reality, like this one. A fundamental conclusion of the new physics also acknowledges that the observer creates the reality. As observers, we are personally involved with the creation of our own reality. Physicists are being forced to admit that the universe is a mental construction. Pioneering physicist Sir James Jeans wrote, "The stream of knowledge is heading toward a non-mechanical reality. The universe begins to look more like a great thought than like a great machine. Mind no longer appears to be an accidental intruder into the realm of matter, we ought rather hail it as the creator and governor of the realm of matter. Get over it, and accept the inarguable conclusion. The universe is immaterial, mental and spiritual." R.C. Henry, professor of physics and astronomy at Johns Hopkins University, The Mental Universe, Nature 436-29, 2005. Are you really going to refer to R.C. Henry as a pseudoscientist? Or Max Planck, or Eugene Weiger? I elaborate on this and go into more detail regarding why many physicists believe consciousness to be a major factor with regards to quantum physics in this article. Consciousness creates reality. Physicists admit the universe is immaterial, mental and spiritual. I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness. Everything that we talk about, everything that we regard as existing, postulating consciousness. Max Planck, theoretical physicist who originated quantum theory, which won him the Nobel Prize in Physics in 1918, it was not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to consciousness. Eugene Wigner, theoretical physicist and mathematician. He received a share of the Nobel Prize in Physics in 1963. And if you want to learn more, I recommend you click the link in the description. From www.power-quadrant.blogspot.com/ and if you like this video, please give it a thumbs up and subscribe and share it with your friends on Facebook and Twitter and Google+. Thank you for watching and see you next time.